Hey everybody, this lesson is called Similar Shapes and Scale Drawings. So here's our common core strand. So you're probably getting close to or in the second semester. So solve problems involving scale drawings and geometric figures, including computing actual lengths and areas from a scale drawing. And you're thinking, what's a scale drawing? Well, we'll talk about that. Architects use scale drawings all the time. So how can we use scale drawings to solve some problems? So scale drawings and scale models are used for map making and construction and other trades. So here's Pete's blueprint showing a layout of a house. Okay, so every 4 inches in the blueprint represents 3 feet of the actual house. So this is 24 inches, so every 4 inches is going to be 3 feet. Okay, so anyways, on the walls of the blueprint is the 24-inch wall right here. Here's a 16-inch wall right here. These other ones we'll talk about in just a little bit. What's the actual length of the wall? Okay, well, there's a couple of ways to do that, you guys. Well, if every 4 inches equals 24, equals 3 feet, if we divide this by 4, so which is 6 times 4 would be 6 times 3 would be 18 feet, okay? So this will be 18 feet, but your book is actually wanting you to complete the table to find the actual length of the wall, okay? So what you can do is, and since they gave us the table right here, so every 4 feet, so plus 4, plus 4, plus 4, plus 4, plus 4, this goes plus 3, plus 3, 6 plus 3 is 9, and then 9 plus 3 is 12, 12 plus 3, and then 15 plus 3 is 18. Either way, you guys, so the length of the wall is going to be 18 feet. So answer the question right there, okay? So here we go, and there's a space right there for a reason. I'll talk about that in just a second. So I'm just going to show you another way to answer this question. You can just do what we did before. So in Pete's blueprint, the length of the side is 16 inches. So find the actual length of the wall. Okay, so 16 inches. Okay, so here we have 16 inches. So the length of the wall is going to be that 12 feet right here. Okay, because that's what our chart gives us right there. Okay, so the back of a house is 33 feet. Okay, so that's this one right here. So 33 feet. What's the length of the back of the wall of the blueprint? Okay, let's go to that back of the wall thing. So it's right here. Okay, so here's the back of the wall. Okay, so they're saying this is 33 feet. So on this map, how many inches is it going to be? Remember, every 4 inches is 3 feet. So if this is 33 feet right there, what we could do is do 33 divided by 3 is 11, and then multiply that times 4, which is 44. But I'm going to show you a different way, okay? So I'm going to just keep including this chart right here, okay? So remember, so our answer is 44, remember. So plus 4, plus 4, plus 4, plus 4, plus 4. We get plus 3, plus 3, plus 3, plus 3, plus 3, plus 3. So let's go 24 plus 4, and then do 18 plus 3. So 24 plus 4 gets us 28, and then 18 plus 3 is 21, plus 4 plus 3. Okay, let's keep going, plus 4 plus 4 plus 4. So plus 4 plus 3, plus 4 plus 4. So we get 27, 30, and 33. So if the back of the wall is 33 feet right there, how much is it on the map? It's going to be 44 inches right there. Okay, so just try to answer this in our regular scale right there. Okay, all right. So how can we see that the answer in number 2 is a reasonable answer? Well, we can. There's several ways. I kind of showed you a couple ways. What you can do is do, since this is a multiple of 3, we do 33 times 3, and this is a multiple of 4, so we do 33 times 3 is 11, and then 11 times 4 gets us that 44. Or we can do this, you guys. Here's what your book said. They said at 18 feet, we got 24 inches right there. So if we doubled this, that's going to give us 36 feet, and that's going to give us 48 inches. And so 36 is a little bit more than 33 feet, and 48 is a little bit more than 44 inches. So that seems reasonable, I guess, you guys. So I think it's better just to do divide by 3, divide by 4. So anyway, so using a scale drawing to find an area. So similar shapes are proportional figures that have the same shape, but not necessarily the same size. Okay, so a scale drawing is a proportional two-dimensional drawing that is similar to an actual object. Oh boy, dang, I thought I fixed it. You guys know me by now. I can't make it through without one misspelling here. So anyways, there we go. Scale drawings can represent objects that are similar or larger than the actual size. Okay, so a scale, you guys, is a ratio between two sets of measurements. It shows how a dimension in a scale drawing is related to the actual size. So scales are usually shown as two numbers separated by a colon. So here's a colon right here. Okay, so a colon is two dots right here. So 1, and this usually says 1 to 20. Okay, or here this says 1 centimeter to 1 meter. Okay, scales can be in the same unit. We can have them centimeter to centimeters, or inches to inches, or feet to feet, or they can be in different units like these guys are. 1 centimeter to 1 meter. Okay, so here we go. So here this is a scale drawing of an art mural. Okay, so the art class is planning to paint a mural on the outside wall, and so the figure, whoops, I forgot my F. The figure is a scale of the drawing of the wall. So what is the area of the actual wall? Okay, all right. So let's get the dimensions first, you guys. Okay, so first find the feet represented by 1 inch. Okay, so here we have 2 inch is 3 feet. Okay, here's our scale right here. So we can represent 2 inch to 3 feet as a fraction, you guys. 2 inch to 3 feet is 2 inch over 3 feet, and that's how we're going to do this, because we can simplify that. Okay, we want to get a unit scale. Unit scale is when the denominator or the numerator is 1. So here we're going to make the numerator 1 by dividing both sides by 2. So 2 divided by 2 is 1. 3 divided by 2 is 1.5. So that equals 1 inch to 1.5 feet. Okay, so find the height of the actual wall labeled by 11 inches. Okay, so here's 11 inches right here. So here's our scale, 1 inch to 1.5 feet. We're going to make that equal to, since this is in inches, we're going to make 11 inches over blank feet, so we'll call it x feet. Okay, so that's what we'll do right there. So multiply that times 11, and we get 16.5 feet right there. So the actual length of the wall is 16.5 feet. We just multiplied it by 11. Okay, let's find the length of the actual wall labeled 28 inches. Okay, sorry, did I say length? This is height right there. So the length is going to be 28. So we're going to do 1.1 inch to 1.5 feet, and we're going to multiply that by 28 over 28. Okay, because the length is 28 right here. Okay, so I'm just going, here's 28, so that's in inches right here, so that goes on top because inches are on top. That's why we multiplied it by 28 over 28. This equals 1, this equaled 1. That's why we multiplied it by 11 over 11, because the height was 11 inches, so inches were on top. So to convert that, we get 28 inches to 42 feet. So the actual, whoops, let me go back, the actual length is 42 feet. Okay, so the final part says what's the area. So area, you guys, is length times width. So we're going to go 42 times 16.5 and get 693 feet squared. Remember, area is always unit squared. In this case, it's feet. Okay, all right, so how can we solve the example without having to determine the number of feet represented by 1 inch? Okay, I like this method much better, you guys, and your book doesn't describe this. If you have a proportion, this is a proportion. When you have a proportion, you guys, a proportion is a fraction equals a fraction. So we have 2 inches to 3 feet. So that equals 28 inches to x feet. Notice inches are on top and feet are on bottom. And as long as we have a proportion with an equal sign, a fraction equals a fraction, we can do this fancy trick called cross multiplying, and I think by now you've done that before. So if we cross multiply, we get 2 times x equals 3 times 28, so 2x equals 84, and x equals 42. So the height, again, use that proportion, equals 11 over x. I'm just using these dimensions. Notice inches go on top because 2 inches over 3 feet. Okay, and when we cross multiply, we get 2x equals 33, and 2 goes into 33 16.5 times. So we can find the area by multiplying 42 times 16.5. All right, so write the scale factor in example 1 as a unit rate, and show that this rate is equal to the ratio of the height of the drawing of the actual height. Okay, this one, you guys, to me it's dirty pool, you guys. It's just these are if I taught an honors class, I would totally teach this to them. But if I'm teaching a just my integrated math 1 class, I'd probably skip this right here. It's okay, it's not hard, you guys. It's just I get less kids that buy into that. Okay, so there's our ratio, 2 inches to 1 feet right there. Okay, so it says show the unit rate. Well, the unit rate is when the denominator is 1. So I divided by 3 divided by 3. So 2 divided by 3 is 2/3. So 2/3 inch for 1 foot right there. And you guys, 2/3 is equal to 0.666666666. Your calculator finally rounded to 7, that last digit right there. So they want us to find, sorry, I went too many right there. They want us to show that the unit rate is equal to the ratio of the height. Remember, the height was 16 inches, and we found it was 16.5 feet from prior. So let's do that. Let's do 11 divided by 16.5. Well, let's do that real quick, you guys. So I'm going to get my calculator and do 11 divided by 16.5. Here's 11 divided by 16.5. Now check this out. 0.6666667, so it equals the same as this ratio right here. So we're going to say that that equals the same ratio as 2/3 inch to 1 foot right there. All right. So this one says, number 5 says, write the ratio of the area of the drawing to the area of the actual mural. Okay, so remember our areas. I forgot what our area was. We'll come back to that. It was whatever 16.5 was times 42 feet. Okay, so write your answer as a unit rate. A unit rate is when the denominator is 1, and show that this unit rate is equal to the square of the unit rate in number 4. Okay, so here we go. So the area of this mural is 28 inches times 11 inches right there, okay, which is 308 inches squared. Let's find the area of the actual thing, 16.5 times 42, because it says find the ratio of that. All right, whoops, I went ahead a little bit. So here's the ratio of our unit rate right here, and they want us to show that the unit rate is equal to the square of the unit rate in number 4. So I'm going to square that right here. So square 2, 2 squared, 2 squared is 4, 3 squared is 9. So we get 4/9 inches squared. We got to square the inches also over 1 foot squared. Okay, so that's going to give us that right there. So somehow we're going to now multiply this times this, which is, I forgot what that was. It was 600, so 693. So we want to show that that is going to reduce to 4/9 squared. So let's divide this by 4 and this by 9 and see if that gets us the same number right here. So here, because they want us to reduce it to 4/9. Okay, so what I'm going to do, whoops, I don't want to do that. What I'm going to do is use my calculator and do 308 divided by 4. I thought I got the calculator, maybe I didn't. Here we go. Math calculator. Okay, so let me clear that. So 308 divided by 4 gets me 77. I don't know. Well, let's do 693 because we want it to get to 4/9 right there. So I want to see, how is this related to 9? Okay, so this related to 4 is 4 times 77. Let's see what 693 is divided by 9. 693 divided by 9 equals Hey, 77, okay? So let's check this out right here, you guys. So we get that equals 4 times 77 divided by 9 times 77, and the 77's cancel, and we get 4/9 inches squared over 1 foot squared, which is what they were asking for. Again, you guys, I don't think I would have given that to my regular kids. I would have given it to if I was teaching honors or advanced math or high achieving or whatever programs your school has, okay? So anyway, so here's another term. So the drawing plan for an art studio shows a rectangle that is 13.2 inches by 6 inches. The scale of the plan is 3 inches to 5 feet. So I have that right there in blue. So find the length and the width of the actual studio. Then find the area of the actual studio. Okay, so I like doing cross multiplying, you guys, and your book doesn't do this. To me, it's so much easier. So I just find it easier to set up a proportion, 3 inches to 5 feet, and then set it equal to 13.2 inches to x feet, and then set it equal to 6 inches to x feet, and that'll give us the length and the width. And then cross multiply. It's so much easier, okay, to me. Okay, so let's multiply these, and then divide by 3. Okay, so we get that. And then, 5 times 13.2 is 66. So 3 goes into 66, 22 times, 22 feet. 5 times 6 is 30. 3 goes into 30, 10 feet times, or 10 times. So 10. So there's our dimensions, 22 feet by 22 feet by 10 feet. And it says find the area. So now we're going to multiply length times width. So 22 times 10 is going to get me 220 feet squared, or square feet. Okay, remember area is always in the answer of a square units. All right, almost done, you guys. So scale of the drawing of a meeting hall is drawn on the grid, that red guy right there, where each square is 1 centimeter. Here the scale of the hall represents 1 centimeter is 3 meters. Okay, so here's 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. So if I multiply that by 3, that'll tell me this is 12 centimeter, or 12 meters. 1, 2, 3, 3 centimeters equals 9 meters. Okay, so the first part says redraw the rectangle above so that it's 1 centimeter equals 6 meters. Okay, so I'm going to just draw it right up above right here. And notice, look, 1 centimeter, 6 meters, 1 centimeter, 3 meters. This guy's going to be twice this guy. So this one is 4 squares. I'm going to make it up here 8 squares. This one is 3 squares, so it's going to be 6 squares. There it is right there. Okay, so note this new rectangle will be twice as large, or the smaller one's going to be half as large as the new one. So there it is right there. So I put the dimensions right there. Find the actual length and width of the hall using the original scale. Okay, so then find the actual dimensions of the hall with the new scale. So remember, the scale is every centimeter equals 3 meters. Okay, so that means right here, let me enlarge that a little bit. Okay, so that means 4 centimeters. 4 times 3 is going to be 12 meters. 3 times 3 is 9 meters. 8 times 3, 6 times 3. Okay, so we're going to get that right there, 9 meters by 18 meters. So explain how you know that there is a proportional relationship between the first and the second drawings. Well, each length of the first drawing is twice the size of the corresponding length of the second drawing. So the rate is, or the proportion is, 2 units to 1 unit right there. All right, you guys, hope that makes sense. Hope you're doing well in math. Take care.